Hi dear students, how are you all today? Are you ready to learn? Do you all like chocolate? Today I am going to say something about chocolate. But before that, can we rewind what we learned in our previous class? What we learned? Yes, we learned about force of gravity. We learned how to calculate force of gravity at the pole and the equator. What did we find there? Where is the force of gravity maximum? Yes, it is maximum at the pole and it is minimum at the equator. Why is it so? The radius of the earth is minimum at the pole. So force of gravity is maximum at the pole and the radius of earth is maximum at the equator. So force of gravity is minimum at the equator. Now do you remember? Have you done the home assignments that I have given to you? What was that? Yes, I asked you to calculate the force of gravitation between Earth and the Sun. What answer did you get? Did you do that? If you didn't do, can we do here? Yes. So, if m is the mass of the Sun, what is the mass of Sun? Do you know? Yes, it is 2 into 10 raised to 30 kg. If small m is the mass of Earth, what is mass of Earth? It is 6 into 10 raised to 24 kg. Okay. So, what is the distance between Earth and Sun called? There is a name for it. Do you know? Yes, it is called astronomical unit. What is the value of astronomical unit? It is 1.5 into 10 raised to 11 meter. Okay. Now using the formula of gravitation, what is that? G into capital M into small m divided by R square. What is the value did we get? What is the value of G? 6.67 into 10 raised to 11. And what is the value of M? It comes to be 2 into 10 raised to 30. What is the value of small m? It is 6 into 10 raised to 24 divided by, what is d here? Instead of r square, it is d square. So what is d? It is 1.5 into 10 raised to 11 meter whole square. Okay. So what answer did you get? Did you get an answer like 35.573 into 10 raised to 21 Newton? Do you get a value like this? Yes. So this is a very large value. No. So is this force significant? Yes, definitely. Since it comes to be in the range of 10 raised to 21 Newton, this force is very large. So what did we understand from this? In the earlier case, what did we saw? The force of gravitation between two men was very negligible, whereas the force of gravitation between our Sun and the Earth is very significant. It is very large. Hence, we can say that the force of gravitation is more depend upon the mass of the objects. When the mass of the object becomes large, the force of gravitation becomes significant. Okay. Now, I gave you another question. Did you do that? What did I ask? I asked that if a man is standing on the surface of the earth and if he tries to fly above, that is if he rises from the surface of the earth, he is trying to rise from the surface of the earth, what will happen to the force of gravity? The force of gravity will decrease. Why? Why the force of gravity decrease? Because the distance is increasing. As force of gravitation is inversely proportional to distance, we can say that as distance increases, the force of gravity decreases. They are inversely proportional. So what if the person go to the center of the earth? Will the force of gravity increase? Definitely. The force of, as a man go to the center of the earth, here distance d decreases. And hence the force of gravity will increase. So this was the answer for my questions. So, how many of you got this answer correct? Is there somebody who got the answer wrong? No, I know all my students might have got the answer correct. Do you all like chocolate? Yes, I told you I'm going to say something about chocolate. Which is your favorite chocolate? Is it Dairy Milk? Is it 5-star or Milky Bar? Yes, I know most of you like Dairy Milk. I also like Dairy Milk, but it's not a problem here. Just imagine that there is an aeroplane which is flying from America to India. This aeroplane is filled with chocolate, your favorite chocolate. And when it came near your house, what happened? A box full of chocolate was thrown down. And you can now collect the chocolate now. Are you happy? You can now go and collect your chocolate. It took around 10 seconds. The plane, if suppose this was your house. So this was your house. And when the plane, so this is our plane. Suppose imagine that this is our plane. Okay. When the plane reached above your house, it threw a box. Okay. This box is full of chocolate, our favorite chocolate. So it is coming in which direction? Definitely it will come in the downward direction. Why? Yes, the earth gravity is pulling it in the downward direction. Okay. Now let me ask you some questions. By answering this question, you will definitely get some points to learn. Okay. So I told that the box took around 10 seconds to reach the earth. How many seconds? It took around 10 seconds to reach the earth. Now, can you determine the height of the plane from the ground? Can you determine the height h? How can you determine the height if the time is given? Do you remember the previous chapters? In the previous chapter, equation of motion, we learned 3 equations of motion. What was that? Do you know? Yes, we learned that the first equation of motion that we learned is S equal to ut plus half at square, where S is the distance, u is the initial velocity, t is the time, a is the acceleration. Then what did we learn? We learned as v equal to ut plus at. And then we learned as v square minus u square equal to 2as. Do you remember this equation of motion? Yes, this is the first clue for you. Now can you find from any of this equation of motion, can you find the height h? Some of you might be knowing this. If you don't know, I'm giving you the second clue. The second clue is that we can find using this equation of motion. You can find the height using this equation of motion. So can I rub the other? So I am rubbing the other equation of motions. If you still didn't get, I am giving you the third clue. When the box was initially thrown out, that is at time t equal to 0, its velocity v equal to u, which is equal to what? Which is equal to 0. And we know that here s is the distance. So s can be replaced by h. So I am writing here h equal to u, which is 0, into t, 0 plus, which is t is the total time taken. Okay, which is, what is the total time taken? I have given you 10 seconds. I have said that it took around 10 seconds to reach the ground. So here t is 10. So half into 80 square. What is the value of a? Do you know? No, we don't know that. We just know the value of t. So I am writing it as 10 square. Okay. So what did we get here? We will get half into a into 10 square. So we will get the value of height if we calculate the value of acceleration. What is the value of acceleration here? Do you know? We have to find the value of acceleration. I will give you some questions. On answering this question, you will definitely come to find out the value of acceleration. Okay, are you ready for that? So can I rub this off? So I am rubbing the above equations. I am writing it here. What did we get here? It's equal to half into a into 10 square. So now we have to determine the value of a. Are you ready for that? Okay. I'm drawing some situations, okay? You have to say. Initially, when time was 0, that is when the box was initially thrown out, what is its velocity? Its velocity v equal to u. We can say that u is the initial velocity. It is 0 that I had given you. After time 2 seconds, where will the box move? The box will move downward, no? It reached here and its velocity become velocity comes to be 19.6 meter per second. After 4 seconds, the box again moved down and its velocity become, how much the velocity? It becomes 39.2 meter per second. After 6 seconds, the box again moved down. What will be the velocity? Will it increase or decrease or remain the same? It will increase. It increased to 58.8 meter per second. After 8 seconds, the box again moved down. Its velocity become now increased to 78.4 meter per second. After 10 seconds, what happened? The box finally reached the ground, and just before reaching the ground, its velocity was 98 meter per second. Okay, this is the situations. Now my question is that what is its initial velocity? Yes, initial velocity was 0. What is its final velocity? Its final velocity is 98 meter per second. Is the velocity uniform? Is the velocity same? Is the velocity 98 in all the situation? No, the velocity is not uniform. It is changing. It is changing with respect to time. So what is change of velocity with respect to time called? Acceleration, right? Is the body accelerating? Is the velocity increasing or decreasing with time? The velocity is increasing with respect to time. So we say that the body is accelerating. So what is acceleration? Acceleration A is change of velocity with respect to time. So we have learned this in our previous class. Okay. Now, in which direction is the Earth's force, that is Earth's gravity, acting on the body? Is it in the downward or upward direction? It is acting in the downward direction. The force is acting in the downward direction. In which direction is the body moving? The body is also moving in the downward direction. So the acceleration, so what about the sign of acceleration? Is it positive or negative? Yes, the acceleration will become positive. Okay, the body is positively accelerating. Okay, so this is the thing that we saw here. The body is accelerating now. Do you remember Newton's second law of motion? Can you state that? So now I am rubbing this off. Can you state Newton's second law of motion? Suppose a body of mass m. This is a body of mass m and it is moving with an acceleration a. Okay, so what is a force that is acting on the body? The force F equal to ma. This is what we have learned in Newton's second law of motion. So in the similar situation, here our body is also accelerating. Here our box is also accelerating. It is accelerating in the downward direction. Okay. And who is pulling the box down? It is our Earth. The Earth is pulling the box down. So the force is acting in the downward direction. So what is this force? This force is due to gravity. So in the earlier class, we determined a formula to find the force of gravity. What was that? Yes, it is G into capital M into small m divided by R square, where G is the gravitational constant. And what is M? Capital M is the mass of Earth. What is small m? It is the mass of object. And what is R? R is the radius, that is average radius of Earth. Radius of Earth. Now do you remember? So we saw that in the earlier case, there was a force acting on the body. So according to our second law of motion, we saw that the force equal to ma. This is according to second law of motion. So according to the universal law of gravitation, the force of gravity equal to G into M by R square. This is according to universal law of gravitation. Now can we equate these two equations? Yes, definitely we can. So I am writing ma is equal to G into capital M into small m divided by R square. Here we have two common factors, right? Which is m, small m. So we are cutting that. So what is the value of A that we obtained? We obtained the value of A to be G into capital M divided by R square. Now let me ask you some questions. Is G a constant? Yes, G is a constant. Is the mass of our Earth a constant? Yes, mass of Earth is a constant. What is the mass of Earth? Do you remember? Yes, it is 6 into 10 raised to 24 kg. What is the radius of Earth? Is it a constant? The average radius of Earth is always a constant. So its value is 6.4 into 10 raised to 6 meters. So now we can substitute the value of G, M and R and see what will happen. So I am substituting the value. So we got A is equal to G into capital M divided by R square. What is the value of G? And who determined the value of G? Henry Cavendish determined the value of G, and it comes to be 6.67 into 10 raised to 11 Newton meter square per kg square. And what is the value of M? It comes to be 6 into 10 raised to 24 kg. So what is the value of R? Radius of Earth, average radius of Earth comes to be 6.4 into 10 raised to 6 meter. So it is R square, so I am putting whole square. So the value of value of A comes to be 9.8 meter per second. Okay, so here we obtain the value of A. So we wanted this value in order to find the height. So we can now easily find the height. So here the box was accelerating in the downward position due to the force of gravity. So I am substituting the acceleration with acceleration due to gravity sign, which is G. So I am instead of writing A, I am writing as G because it is accelerating due to gravity. So G comes to be 9.8 meter per second. You should always remember this value of G. It is very important for problems and to understand much about science. So now we can substitute the value here. So what is the height now? Height comes to be half into, instead of A we are writing G, into 10 square. So what is it? Half into 9.8 into 10 square. what value did you get? It comes to be 490 meters. So here we saw that if this was your house and this was a plane and the box was thrown from the plane, and now we can easily calculate the height at which the box was thrown when the time taken to reach the earth was given to be 10 seconds. So the height comes to be 490 meter. The plane was at 490 meter above the earth when the box was thrown out. So do you understand how did we calculate? In order to calculate the value of height, we determine the value of g. So do you remember how did we determine? Now let me ask you some question. What will happen to the value of g if we move to the pole of the earth, north pole of the earth? What will happen to the value of g? Will the value of g become more or less? How can you know this? When you move to the pole of the earth, sorry, this is not the shape of earth. Yes, if you are moving to the pole of the earth, we have seen that the radius is minimum at the pole. So the force of gravity was maximum. So force is directly proportional to acceleration. So instead of A, I am writing acceleration due to gravity. So acceleration, since force is maximum, acceleration due to gravity will also be maximum. And its value comes to be 9.87 meter per second square. So meter per second square is a unit of acceleration. Acceleration due to gravity at the pole comes to be 9.87 meter per second square. So what about acceleration due to gravity at the equator? What will be the value? So at the equator, we saw that the radius is maximum. So the force of gravity at equator will be minimum. Force is directly proportional to acceleration. So instead of A, I am writing it as G. So G will be minimum at the equator and its value comes to be 9.78 meter per second square. Okay. So this is a value of G at the pole and this is a value of G at the equator. So average anywhere on the earth, we can write the average value of G to be 9.8 meter per second square. So this is all about what we have learned in this chapter. We learned how to determine the value for acceleration due to gravity. Now if I am giving you some question, will you be able to answer?
How good? Put it down.